one of these days I'll actually remember what page it is. What is it, 63? Thank you. Oh. All right, page 63. And we're done. So today we're going to write the equations, where yesterday we had the factored form and then we graphed them. So we're going to start by graphing them again, just so that we can talk about what happens and make sure that we actually understand what's going on. So this is the function in factored form, right? This is factored. So we want to look and we need to find the zeros. So what are they? 4, positive 1, and negative 2, right? So it's going to help to do this. Negative 2, 1, 4. We can all figure that out with ease, yes? I'm also going to need the y-intercept, okay? So the y-intercept is when x is 0. So when I plug in 0 here, this is going to give me negative 4 times negative 1 times a positive 2, right? Remember, that is not the same as your zeros. There was a little bit of a confusion yesterday for that. So this is going to be positive in the end, and I get a positive what? 8. Okay, so my y-intercept is a positive 8. I can go ahead and graph that right there. Okay, so as long as I say that it's 8, it's 8. And then I only have to go to 4, so we'll make 5 of these. And then I want to make sure, here's at negative 2, that I actually label the points. 1 and 4. Oh, that's 5. Oof. 4. And then what's the degree of this polynomial? Bless you. 3, okay, and the leading coefficient, positive or negative? Positive, okay. So it's positive with a degree 3. Show me with your arms. What's it going to look like? What's the end behavior? Come on, everybody. Zeke, I know you weren't here. You're going to have to do it too. Here's our end behavior. Other arm down. Oh, yep, see? Oh. It's going to look like this. The other way. Okay, there you go. Okay, right? This is like a cubic. So here's our end behavior. So we're just going to sketch this for ourselves just so that we know what's going on. So there's our end behavior. There's our points. Do we have any roots that have a power greater than 1? No. Okay. So that means nothing's bouncing. We don't have any points of inflection, nothing like that. But because of end behavior, I have to start down here. I'm going to cross the x-axis at a negative 2. Remember, I have to go up through 8, but it's not necessarily, that is really bad. It is not necessarily the maximum. Oh my gosh, I did that again. Maybe this is much better on a piece of paper. Kind of looks like my maximum. That's okay. It's going to come back down and then come back up, and I'll make sure that this matches my end behavior, and we're good. Because not necessarily, no. Yeah, so like in this case, mine kind of looks like it is, but it doesn't have to, and I was trying to make it not look like that, but I'm not that talented on the board. My paper looks much better than I did by hand, but a little piece of paper with a pencil, I can handle that a little bit better. No, but you don't, right now we don't know, we don't care. We don't know how far down this goes, we don't care. We're just trying to get the other key points. I'm never going to say never, because yeah, it's possible that it could, and if it did, then you would use that. If not, it's not even anything we're concerned with right now. Okay, it's a good question. All right, we good? All right, so let's look at number 2. And then I'm looking for my zeros. So look at number 1 and number 2. What's the only difference? The negative, right? Which means that my zeros are the same, yes? Negative 2, 1, 4. My y-intercept, what's the only thing that's going to change? Am I still multiplying the same numbers together? Yes, I just changed the sign, so it's negative 8. So I can go to negative 8 down here, and then 1, 2, 3, 4, 5, 1, and 4, and negative 2. Okay. In behavior, this is a degree of 3 with a negative leading coefficient. So what does it look like? Everybody show me. With your arms. It's negative, see? There we go. Okay. All right, good. All right, so in behavior is going to look like this. Right here. So this time, I come down. I'm going to try harder to make this not my maximum. Comes back up. My shoes are very squeaky. I don't know why. We good? Any questions? Okay. Next one. Now, my zeros are what? -1, +2. Anything special about either one of them? The squared, which makes this right here a double root. When it is a double root, what happens at the axis? It bounces off, right? Okay, so we're going to bounce off the axis here. This is a bounce. All right. Then I need my y-intercept, so y is equal to 1 squared times a -2. So that gives me what? -2. I know, these questions are really hard for me. So here I am at a -2. Then I have a -1 and a 2 for my zeros. And this has a degree of what? What's the degree of this polynomial? 3, right? So, and the leading coefficient is positive. Therefore, it looks like this, right? Y'all are getting lazy on your end behavior. I want to see it. Everybody. Waiting on your end behaviors. Table 1. Flip it. The other way. Okay, good. All right. Cubic, so it's going to looks like a cubic. Or it looks like it is a cubic, but it looks like the parent function as far as the end behavior is concerned. Okay, so I start from down below, right? And then it's what happens at -1 since it's a double root. It's a bounce. Because look at this. If I don't think about that, but I know it starts down here, if I go up, I can't come back down until 2, and I don't hit my y-intercept. That make sense? So right then, if you try and do that, you should realize something's wrong because I can't make it come back down here. But it's supposed to bounce off the axis right here, like something like that, right? So it's going to come down, or it's going to go up, and then bounce off the axis, come back down through the -2, which is not necessarily the, oh, gosh, these are bad. It's not necessarily the minimum. That's a little bit better. Everybody good? That's why you want to think of all those things. What the end behavior is, what your y-intercept is, all that stuff, so that if you do try and do something that doesn't work, you should look at it and just say, something's not right. Okay. This one, what are my zeros? 4, right? So anything special about this? It's a cube, so this is a triple root. At a triple root, what happens at the x-axis? It's a point of inflection, right? And who wants to tell me what that even means? What's a point of inflection? Change in concavity, right? From concave up to concave down, or vice versa, whatever's working there. Okay, good. So then I've got to find my y-intercept. So y is equal to -4 cubed. So what's -4 cubed? -64, and then it's negative, so it's a +64. So I'm up here at 64, and then this is the only time that it crosses the x-axis. And leading coefficient is negative, and this is a cubic, so what's it going to look like? Right? In behavior. Which way is it? You tell me. Mine's backwards. This way, right? Okay. So that should make sense because I can't really start over here and go through the axis and end up over there, right? So I've got to start over here. My end behavior is going to look like this. Everybody understands your end behavior based on that, right? We're all good on that? Okay. So it's going to have to come down from infinity, cross at the axis, and then the concavity changes, right? So I was concave down, now I'm concave up. And I didn't label that this is 4. That's important, so do that too. Everybody good? So all these same things that we identified before we graphed it, we're going to have to identify from the graph so that we can write our equation. Okay, let's go to this next one. It says, use the given information to write an equation for each of the following polynomial functions. So on here, these graphs leave a lot to be desired, but it's taken off of a calculator with bad pixelation, so that's why it looks like it does. But I can tell, hopefully, that this is the axis. This is right here at, what is this? 4, right? 1, oh, that's 5, oh my gosh. 1, 2, 3, 4, 5. This is at -2 and -3. So my roots are -3, -2, 5. Now, you know how we graphed the equation? Sort of, we sketched it because we weren't really graphing it, but we don't really know how high and low it goes at certain points. This says, use the given information to write an equation for each of the following polynomials. This word right here tells you something. It says write an equation, not the equation. We don't actually have enough information to write the true equation either. Just like we didn't have enough information, well, we did, we could have found some more, but we didn't really find enough information to actually graph the polynomial. We don't have enough information to actually write the specific equation for this cubic. So it's an equation. So make sure you're paying attention to those things in the directions. So if these are my roots, is it pretty easy to come up with my factors? Yes. If I have a -3, that means this is x plus 3, x plus 2, x minus 5. Everybody okay with that? Now, here, it just says in factored form. I have to write the equation. I pretty much already have that. F of x equals x plus 3 times x plus 2 times x minus 5. Right now, we're not going to have x have a coefficient in front of it, but we will be able to find a, which would go right here in the next one that we do. So that's a good question. And if x had the coefficient, actually, if x has a coefficient, that's because this would not be a whole number, is what that would come from. Does that make sense? So that is definitely possible if I had a fractional root there. Right now, we're just going to look at whole numbers for that, though. That's a good question. So this next one says find the equation. That means I got enough information to be specific because it gives me a point, right? So we're going to start the same way, and we're going to look at our roots. I'm here at 1, -3, -4. Everybody okay with that? And so my roots are -4, -3, 1. So I'm going to be able to find a here. There is something up in the first one I should have talked about. Even though we can't find a, looking at the end behavior, I know you can't see much of it, but clearly it comes from down here and then comes back up like this. So if my end behavior looks like this, is the leading coefficient positive or negative? Positive. This would be a. So I at least know a is positive, but that's pretty much all I can do, right? So here, when I look at this, what do you know about a? It's negative because your end behavior looks like this. So this means a is negative. But we will be able to even actually find the value of a at this point. So here are my roots, which means my factors are x plus 4, x plus 3, x minus 1. Everybody gets why it's that, right? I need to focus on that. All right, so when I write this in factored form, right now I don't know what a is, so I'm just going to write it down. I'm going to say, all right, well, I know that f of x equals sum A, don't know what it is yet, but I know it's going to have to be negative when I'm done, times x plus 4 times x plus 3 times x minus 1. Everybody with me so far? So what do you think I can do to find A? Plug in the point, right? We have a point that gives us x and y, so we can plug in the x and the y and figure out what A is going to be. So I'm going to take this and I'm going to substitute for f of x, I'm going to substitute 12. That's equal to A times negative 1 plus 4 times negative 1 plus 3 times negative 1 minus 1. Everybody understands where all that came from, right? Yes? Okay, good. So that means I'm going to get 12 equals A times, it's going to be a positive 3, positive 2, negative 2. So what's negative 2 times 2 times 3? Negative 4 times 3 is negative 12, so I get negative 12A. So what does A equal? Negative 1. Now, just because A is negative did not guarantee us that it would be negative 1 up there, because it could have been a negative 5, a negative whatever. It just happens to be a negative 1. So now I can actually write the equation that it's asking me for. So I get f of x equals, A is negative 1, so I can really just put minus, then x plus 4 times x plus 3 times x minus 1. Is it wrong if you put negative 1 right there? No, but you're never going to see it that way, and that's not really what is supposed to be there. So this is our final answer. And so if we plugged this into the calculator, we would get this exact graph. If we plugged this into the calculator, we may or may not get this exact graph, only if A would happen to be 1. Does that make sense to you? Any questions at this point? We good? All right, let's do the next one together too. All right, so what are my roots here? Negative 4 and 1. Now, do I have enough information to find an equation or the equation? An equation, right? Like I can't find the actual one, that's okay, but I'm going to find what I can find. Anything special about either one of these roots? It bounces. So what does that tell you about this negative 4? It's a double root. Okay, this is a double root because we have a bounce, right? This is our bounce right here. Very important. So when I go to write my factor, x plus 4 squared, and then x minus 1. Everybody okay with that? So now I've got, it says just polynomial form, so f of x equals x plus 4 squared times x minus 1. This is not polynomial form. This is factored form, which means I got to multiply it out. Please tell me y'all are past the whole, oh, this has to be x squared plus 16. Because I think in pre-cal, my head might literally explode if y'all did that, okay? You have got to be way past that, right? We're way past, it is not x squared plus 16. Okay, so f of x equals x plus 4 squared is x squared plus what? 8x plus 16. Yay! Okay, and then, I know, not something I should even be celebrating in pre-cal, times x minus 1. So then I'm going to distribute that x, so I get x cubed plus what? 8x squared plus 16x. Yes? Then I'm going to distribute the negative 1, so I get negative x squared minus 8x minus 16. So f of x equals, got x cubed, then what? 7x squared plus 8x minus 16. Okay, there we go. That's what we have in polynomial form. This is an equation that could represent that. We good? All Number 8. We are going to find the equation for the following if it passes through this point right here. So starting with our roots, -3, 2, 6. Yes. Okay, so we got -3, 2, 6. Anything special about any of those? Any bouncing or inflections or anything? No. All right, so my factors are x plus 3, x minus 2, and x minus 6. So I'm supposed to do the polynomial form. I'm first going to write down the factored form. Now, since I have enough information to find a, I'm going to put my a here. This is x plus 3 times x minus 2 times x minus 6. Now, because I need it in polynomial form, at some point I've got to multiply it all out. I could multiply all this out right now and then find a, but that would be yucky because then I'd have an x cubed and stuff in there, and I just might as well not do that, even though x happens to be 1. We'll just go ahead and plug it in like it is. But tell me, is a positive or negative based on your graph and in behavior? Positive. Okay, good. So I have that point. I'm going to substitute that in. F of x is 80. That's equal to a times 1 plus 3 times 1 minus 2 times 1 minus 6. So 80 equals a times 4 times a negative 1 times a negative 5. So 4 times a negative 1 times a negative 5 is what? 20. So I get 20a. So a is 4. Everybody with me? Stop me if I lose you. Okay, so now I've got to write my equation. Oh, sorry. So that means that I have f of x equals 4 times x plus 3 times x minus 2 times x minus 6. That is the factored form. It's asking me for the polynomial form, so I have to multiply it out. So you have options as to how you want to multiply it out. What I would do is I would go ahead and take these first two together, so that gives me 4x plus 12, and then multiply the second two together, so that gives me x squared minus 2x minus 6x is minus 8x plus 12. You need to hopefully be way past trying to put this in a box. In AP stuff, you don't have time to draw a box. Okay, you have to just go with it. All right, so then I'm going to distribute that 4x. So I've got f of x equals 4x cubed minus 32x squared plus 48x. All right, so distributing all that. Then I'm going to distribute the 12, so that gives me plus 12x squared minus 96x plus 144. All right, y'all check me. I didn't mess any of that up, did I? Right. Where did I get the 12x squared? Okay, these first three were from me distributing the 4x, and then I distributed that. Yeah. Okay, there you go. And then I distributed that to get that one. Okay, we good? Okay. So then I just have to combine all my like terms. F of x equals 4x cubed. So I have a negative 32x squared and a positive 12x squared, so that's negative 20x squared, positive 48, and negative 96. I probably should have put the negative down here. Negative 96 right here. So this gives me a negative 48x plus 144. Do y'all agree with that? Yes. We good? Any questions about this? All right. Think in behavior. Think about, you don't know the y-intercept on any of these, but they may give you some other random point so you can find a. Okay, we all good? Awesome. Go ahead and glue those in. And